Okay, I'm going to go over the test so that we don't have to do that in class and you can look at it. So let's just go over these first questions. The first one, car starts at, and this is for both sections of my class, so I'm going to go through two tests. Car starts at 0.5 meters and has a velocity, blah, blah, blah. What will the car's velocity be at a time of 0.4 seconds? So this is, this is your standard velocity update formula from that numerical calculation. So based on the definition of average velocity and the definition of acceleration, I can find the velocity is the final velocity is the initial plus acceleration times the time interval, 0.2 seconds. And so I just put in my stuff. Boom, boom, boom. The velocity, the acceleration, the time, I get 0.44 meters per second. And that's the velocity update formula. Now the next question, where will the car be at 0.4 seconds? Now this one you could do two different ways. I'm going to do it the numerical calculation way. So here I'm going to say the definition of average velocity is the change in x over the change in t, and I get the velocity the position update formula. x2 is x1 plus v2, not the average. So I'm just going to use this velocity. You could use the average if you wanted to. And that's, so I put in 0.5 meters, I put in 0.44 meters per second, and 0.2 seconds, 0.588. Now, I saw a lot of people on this one, and there's another problem, saying this. Don't do that. That is bad. That is super bad. Super, super bad. It's only true in certain cases. It's not a good way to do it. Don't do that. Don't. Okay, and the other thing, in all of these problems, showing your work is not this. Some people said, oh, I'm going to show my work. I'm going to say, X, boom, 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 I showed my work. No, this is the showing your work. Okay, this is explaining the solution. This is just putting in your numbers. So that's one thing. Next one. Some students collect data on a car moving on a track, and they get the following. So this is position versus time, and you want to find the slope of this line would be the change in position over the change in time, which is the velocity. The delta x over delta t. It's not delta y over delta x. Okay, that's the generic formula for slope if this is y versus x, which it's not. It's change in x over change in t, and that's the slope. Okay. The other thing is you want to use points on the line, not the. If I use this point and this point to find the slope, I'm ignoring the other points. So you don't want to do that. But I got the change in x for those points over the change in time. I get 0.22 meters per second. A ball launcher shoots a ball with a speed of 2.1 meters per second, and it starts 0.9 meters above the floor. How far does the ball move before hitting the ground? So here's my picture. I break this into an X motion and a Y motion. Let's look at the Y first. So I have Y2 is Y1 plus V0t minus 1/2 gt squared, and the initial velocity is 0. I can solve for the time, square root of 2h over g. Now in the X motion, I have the x2 is x1 plus v0 in the x direction, which is not 0, t. And I know t, so I can solve for x2. So there, boom, plug in your numbers, boom. Plug. Again, I saw lots of people for this case say this. X equals vt. That's not so bad, but I saw a lot of like v equals d over t. That's just not true. Okay, please don't do that. Okay, I feel better now. Okay, last one for this section, which is section 8 on morning class. So here is a block and has a mass. It's frictionless. 2 spring scales are pulled on it. One pulls to the left with a force of 0.55 newtons, or then pulls to the right at some angle with a force of 0.81 newtons. This is just like in class. So I have a force pulling that way, force pulling that way at some angle. What angle does it have to be at? So I know the x component of forces have to be equal. So I know that one is 0.55 newtons, and this is 0.81 times the cosine of this angle right here. So I have net force f2 cosine theta minus f1. I solve for, I know f2, I know f1, I can solve for theta. Boom, 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 47.2. Next test. This is the second one. Car rolls down the track and passes through a photo gate. Hopefully you can see this is just like what we did in class. So I gave you the time to the gate, the gate time, how long it takes to pass through the gate, and the gate distance. So where the gate is. So I can find the velocity at each one of these points by taking the distance to pass through the gate. The flag length of 0.8 meters divided by the gate time. So I get that. And that's exactly what we did in class. Then I can plot velocity versus time, and I get this. Straight line, and I find the slope. The slope of velocity versus time is change in velocity over change in time, which is the acceleration. So again, I pick points on the graph line, not the data points. Change in v over change in t, I got 0.39 meters per second squared. Another ball launch problem. I shoot the ball horizontally. In this case, I measure the height and the x and what's the initial velocity. So the x motion is the same as the last one, but I don't know time. The y motion is the same as the last one, but I can calculate the time. I plug that time in over here, and now the only difference is I solve for v. So v is x2 over t, and that's going to be 2.1 meters per second. It's the same problem. Again, another pulling a block problem. In this case, I gave a mass, which you don't need. I pull to the right with 0.75 newtons at an angle of 55 degrees. And the question is, how hard do you have to pull to the left? So it's the same problem. So net force is 0. So F1 cosine theta minus F2 equals 0. So now I'll just solve for F2. F2 is equal to F1 cosine theta. 0.75 times cosine 55, 0.43 newtons. Okay, two cars have constant speeds. This is from the first lab. Car A is going at 0.11 meters per second. Car B is 0.22 meters per second. Car A starts off at a position 17 centimeters in front. So here is the equation for car A. It starts off at 0.17. It starts off not at 0. So the position is initial position plus velocity times time. The other one started at 0, so its position is velocity times time. And so I want to find out when they are at the same place. So that's when XA is equal to XB. So I can set this equal to this. I get that's the position for car A, that's the position for car B, and no VA and VB, I'm just solving for T. I get 1.55 seconds at the end.